All right, if you've ever used an AI coding partner, you know exactly how this goes, right? It's amazing at first, everything is humming along, and then boom, it just breaks. Well, today we're going to dive into a new way of thinking, a methodology that's built to fix one of the most frustrating parts of working with AI.
Sound familiar? I mean, you're deep into a project, the code's getting complex, and all of a sudden your AI buddy starts suggesting things that completely contradict what you decided on yesterday. It's that sinking feeling when you realize, wait a minute, I'm not coding anymore. I'm just correcting a machine full-time.
Well, there's a name for that exact point of diminishing returns. It's called the context wall, and it's exactly what it sounds like. An invisible barrier you slam into where the AI's memory just seems to, well, completely reset. The entire context of your project just evaporates into thin air.
Okay, so let's break that down. What is this wall, really? It's pretty simple, actually. It's what happens when your project just gets too complex. The AI is trying to hold all this information in its virtual head, and eventually it's just too much. It starts dropping crucial details, which leads to those totally conflicting and, let's be honest, useless suggestions.
But what if there was a way to give your project a permanent memory? Like a shared brain that both you and the AI can read from and write to. Well, that's the whole idea behind the design log methodology. It's a system that's literally designed to tear down that context wall once and for all.
So what actually is a design log? It's way simpler than it sounds. It's just a folder right there in your Git repository, usually called /designlog/. And inside, you've got these markdown files. Each one is like a perfect snapshot in time, capturing all the thinking behind a feature right when it was designed. It basically creates a living history of your project's decisions.
And look, this is totally different from your standard documentation. Think about a README file. It's always trying to describe the current state of the code, right? And we all know how fast that gets outdated. A design log is the opposite. It's an unchangeable record of the why and the how of a decision. It creates this permanent breadcrumb trail of logic that the AI can always follow.
Okay, that all sounds great in theory, but does it actually work in the real world? Let's take a look. We're going to walk through a real example from a project called the J Framework. The task was to add a new feature they called server actions. In simple terms, they needed a way for the app on your screen to talk to the server.
The whole process basically boiled down to these 4 steps. First, you've got a really simple prompt to kick things off. Then the AI steps up and acts more like an architect than a coder. After that, a human comes in to review the blueprint. And finally, you get this super focused implementation that doesn't wander off track.
Now check this out. This is the prompt they started with. Notice what's not here? There's no giant 10-page spec document, no super detailed, long-winded explanation. It's just a clear, simple, high-level goal. That's it. That's the whole prompt.
And this is where the magic of the methodology kicks in. Because of the rules we're going to talk about later, the AI didn't just start spitting out a bunch of code. No way. Instead, it created a new design log and started asking questions. It dug through the existing code, found similar patterns, and started a conversation. It was basically co-designing the entire feature in plain English before anyone wrote a single line of TypeScript. So after that back and forth, that whole Q&A session, the AI produced a really clear blueprint. The first piece of the puzzle was the server side, what the API should look like there. And this is what it came up with. This is the actual code snippet it proposed for the server. You can see how clean it is. It defines the contract, handles the services, the caching, the logic. Everything's right there. By getting this locked down first, everyone, both the human developer and the AI, is working from the exact same playbook. Of course, that's only half the story, right? You got the server, but what about the client? The AI also laid out exactly how a developer would actually use this new function from the front end.
And there it is. Super simple, really elegant. Because both sides of this equation, the server and the client, were defined right there in the design log from the start, there are no surprises down the road. The plan is set in stone.
So what's the payoff for all this upfront planning and collaboration? Get this. The entire feature, from that tiny little prompt to a fully tested, ready-to-merge pull request, was done in just 48 hours.
I mean, 48 hours for a core feature like that is pretty incredible. But it's not magic. It's the direct result of a huge shift in how the work gets done. So let's pull back the curtain and look at the secret sauce here, why this whole thing actually works so well.
It really comes down to 3 massive changes in the workflow. First, you get these magic, simple prompts because the AI's job is to go read the logs to get its own context. Second, you get this Socratic collaboration,
where the AI asks questions to nail down the logic before anyone codes, when changes are still cheap. And third, the implementation becomes traceable. The code can't just drift away from the plan because the plan is documented.
Okay, so you might be thinking, this is great, but how do I actually do it? Well, it all boils down to a clear set of rules. 4 pillars that you can literally give to your AI as system instructions to make it play by these new rules.
And here they are, the 4 pillars. Number 1, read before you write. The AI has to check the design log first, period. Number 2, design before you implement. It has to create a log and get it approved before writing any code. Number 3, immutable history. The design part of the log gets frozen, and implementation details are just added to the end. And number 4, and this one is crucial, the Socratic method. If the AI is missing info, it absolutely must ask questions, no guessing allowed.
This quote from the author of the piece, Yoav Abrahami, I think it just perfectly sums up the whole thing. It's about moving away from just hoping the AI gets the vibe of your project to knowing it understands the architecture. Why? Because you wrote the history of that architecture together.
And really, that's the ultimate result here. When you create this shared brain, this collaborative history for your project, the whole development process just transforms. Things move faster, the quality of the code is way higher, and maybe most importantly, the whole thing becomes predictable. No more wild goose chases. Which kind of leaves us with this really interesting question to think about, doesn't it? Maybe the future of coding isn't about becoming an expert prompt engineer, crafting these huge, elaborate instructions. Maybe it's more about becoming a co-author, a project historian, carefully building that shared understanding with our AI partners, one design log at a time.